Are you concerned that melatonin is becoming more and more popular as a way to solve lifestyle issues that have caused sleep impairment? Because I'm seeing loads of, I'm an investor, so I see lots of companies now pitching me different products that have melatonin in them as a sort of day-to-day sleeping supplement.
I think I'm really torn. I've been on both sides of this argument, and I'm cautious about it for two reasons. The first is in pediatric populations here in the United States.
Pediatric?
Yeah.
What
so
does that mean?
The people's use of melatonin in kids is increasing. So in pediatric populations, it's increasing exponentially. And in fact, if you go down the sort of the supermarket aisles here in America, often if you go into sort of the health sort of food section, there's this big purple section. That's the melatonin section. And a large proportion of that is they're dedicated to gummies for your children with melatonin. And there was a study that was published about 3 years ago that showed here in America, over the past 10 years, there has been a 503% increase in poisonous overdose admissions to hospitals of melatonin in the past 10 years. 503% increase. So firstly, we've got to be a bit careful. The second reason is that melatonin is a bioactive hormone, and it's also involved in reproductive development. And there were studies done back in the 1970s, I think, where they were looking at juvenile male rats, which is to say male rats who were going through adolescence. And they were dosing them with high amounts of melatonin. And what they found is that that stunted the development of the testes, of the testicles, and it caused testicular atrophy. Now, these were very high doses, but we've got to be a little bit careful. We say, well, melatonin's a natural hormone, so anything natural is safe. Melatonin overall, in terms of its safety profile, is very safe. It's actually a very good antioxidant. But you've got to be careful because things like, for example, testosterone supplementation in males, what we know is that if you're injecting testosterone, after a while, after maybe 18 months or so, the testicles themselves will stop producing their own testosterone. And even if you stop the administration of the exogenous testosterone, the injection, the testes never return their function of producing testosterone. Now, we don't have any evidence yet that that's the case, that if you keep taking melatonin at high dose, your body, the fear would be, shuts down its own natural production of melatonin. I've seen no evidence of that. In fact, I've seen evidence the contrary, that even after about 6 months or even 12 months in certain small cities, when you stop melatonin, the production starts again naturally. It seems fine. Problem is, people haven't been taking melatonin for just 12 months. They've been taking it for years. We've got no idea what happens after years.
That was my hesitation when the first time someone offered me melatonin. Is from doing this podcast and speaking to smart people like yourself, I've come to learn this sort of principle that if you start making something for your body in terms of a hormone, if you start sort of consuming something externally, like testosterone, your body will say, fine, I don't need to do this. It'll try and return to that level of balance where the quantities in your system are maintained, which means it kind of learns to shut down. And I always think about the case of testosterone, because men know that if we start injecting testosterone, then we're going to have to pretty much do it forever.
Yeah.
If we want those levels to be the same.
But yeah, that's the worry, is that there are no free lunches in biology. And usually if you fight biology, you typically lose.
There's always a trade-off. And so when my friends often talk to me about these miracle things or this thing or take modafinil and everything will be fine and da-da-da-da, I go, yeah, but what's the trade-off? And I get most concerned when they say there isn't one. Because then I go, shit, we don't know it.
Yeah, you've got to be careful because absence of evidence is not evidence of absence. Be very careful when you're doing that deal with your physiology. So to come back to the three things, the first thing we were mentioning is digital detox. And don't worry about the blue light. Worry about light in general. I'll come on to that because that's the second. But Michael Gradazar, as I was saying, what he found is that the blue light doesn't really disrupt your sleep. It's a combination of, first, these devices that we use are attention capture devices. And they are designed to fleece you of your attention economy. And they do it ruthlessly well. They've spent tens of millions of dollars designing these products to do that. So what happens is that these devices become hugely activating. And as a result, they essentially will be a mute button on your sleepiness. So you could be there, you get into bed, it's 11 p.m., you think, I am so tired, I was falling asleep on the couch watching television. And then you get into bed, you start going onto social media, and then you start doom scrolling, and then you get into this what we call bed rotting, where you just sit there, and now you look at the clock, and it's no longer 11 p.m., it's 1 a.m., and you've just done sleep procrastination. Now, it turns out that it's, yes, that these are attention-grabbing devices that will mute your sleepiness. But you have to be of a certain personality type, he found. Not all of us are vulnerable to this sleep disruption of devices. You have to be someone who is perhaps neurotic, someone who has high impulsivity, or someone who is perhaps high anxious. If you are of any of those kinds, you should be really careful about your use of technology in the bedroom. Now, for me to, sit here and say, look, put your phone in the car, in the garage, and that way, that's what I would love. Because what we've learned to do in this modern era is the first thing when you wake up, what is it that you do?
No comment. I'm not telling you.
It's just you and I, Stephen.
I grab my phone before my eyes are even open.
And what happens is this sort of small tsunami of anxiety washes over you, because as soon as you unlock the phone, it's everyone else's agenda for your day but your own. And it's a terrible way to wake up. Have you ever had the experience where you've got to wake up for an early morning flight, and it's a critical flight? You know that night is not going to be a good night of sleep. It's going to be a shallow kind of sleep. It's what we call anticipatory anxiety. You are anticipating an anxious event in the morning. And studies have shown that when we create this anticipatory anxiety, the amount of deep sleep that you have drops significantly. You don't sleep as well. And therefore, if we just do this little sort of version, this LITE version of the morning flight, which is we know that when we go to bed and we put our phone down, we know that when we wake up every morning, we're just going to open it up to that hit of anxiety every morning. No wonder our sleep can start to get shallow. Now, I'm not going to sit here and say, well, don't take your phone into the bedroom, because the genie is out the bottle, and no matter what I say, it's not going back in anytime soon. And a friend of mine, Michael Grandner, has got this beautiful framework where he says, you can take your phone into your bedroom. It's fine. But you can only use your phone standing up.
Oh. What's his name?
Michael Grandner. He's
Tell
brilliant.
him to mind his own business.
and what happens is that you're there and you think after about 7 or 8 minutes, I'm just going to have a bit of a sit down here. As soon as that phone goes away. So I would say that digital detox is the first friend that will really help your sleep. The second is regularity, and we'll come on to regularity when we speak about, what really makes for good sleep. If you were to only do one thing, not 3 things, but just one thing, go to bed and wake up at the same time, no matter whether it's the weekday or the weekend, regularity is king.
Okay, so that's the third pillar.
That's correct. Regularity.
Okay.
When I looked at the science, for me, I created this framework of the 4 macros of good sleep. You've heard of the 3 macros of food, macronutrients, fat, protein, carbohydrate. To me, there are 4 macros of good sleep, and it's QQRT, and it stands for quantity, quality, regularity, and timing. And think of it less like pillars, but the 4 legs of a chair. And if any one of these becomes unstable, the chair will topple over. So I'll probably start with the one that people have heard me bang on about, which is quantity, 7 to 9 hours. This myth of 8 hours is nonsense. It's a wonderful range, 7 to 9 hours. And what we know is that using that sweet spot of 7 to 9 hours, when you get less than that, the shorter your sleep, the shorter your life.
Fuck.
Short sleep predicts all-cause mortality. Now, we say that there's the minimum of 7 hours of sleep. And some people have argued, perhaps correctly, that, look, if you look at these mortality curves, there's not much of a percentage difference between sleeping 6 hours versus the 7 that you're telling me is minimum. So 6 hours is just fine. So all of this nonsense and rhetoric is silly from you. And I think they've made a conflation, because 7 hours is the minimum amount of sleep that you need to survive. Because the way that we quantify what minimum is based on whether you die or you don't prematurely. The amount of sleep that you need to survive is different than the amount of sleep that you need to thrive. And people will conflate the former with the latter. So you've got to be careful when people are sort of touting on social media. They're saying, well, no, but look, there's not much difference between my sort of survival rate on 6 hours versus 7 hours. You may have just as much of a long life, but the quality of your life will be very different. So that's quantity, 7 to 9 hours.
And does it change for parents, by the way? Because I've met so many parents that seem to be functioning better than me, and they're having like 4 or 5 hours sleep. Did evolution not give parents any leeway or anything when they have kids that suddenly their brain changes and now they can survive with less sleep?
The evidence doesn't suggest that once you go through parenthood, you get some magic sort of, immunity shot that makes you, resilient and not vulnerable to a lack of sleep. And in some ways, you could argue, because we used to, live as a collective tribe and we would share duties, at that point, Mother Nature doesn't really worry too much about you now because you've already procreated and you've passed on your genetic code. So you are now the not particularly well, cared for individual through evolution. It's your offspring that gets.
So it sacrifices you in a way. I mean, that's what we see in the animal kingdom. Did you see that documentary about the octopus?
Yeah, it was just, I thought it was a beautiful documentary, but
the TLDR for anyone that hasn't seen it is once the octopus, and I'm going to completely butcher this, so please ignore. Once the octopus has given birth, it dies. Basically, it doesn't move out of that hole, and it dies? Is that rough?
Well, I don't know if it dies, but its level of active life.
I searched, does the octopus die after reproduction? And it says yes. Female octopuses die after their eggs hatch. After laying eggs, a female stops eating and devotes all of her energy to protecting and oxygenating them until they hatch. Once they do, she dies shortly after, a process called semiluparity, meaning they reproduce only once. This death is triggered by hormone changes from the optic gland, similar to mammalian pituitary glands. And males die shortly after mating as well, usually within a few months. That is wild.
In some ways, it's tragic, and it reminds me, I'm so glad that I'm not an octopus. But coming back to it, so there doesn't seem to be some, magic cloak of invincibility that you put on when you go through parenthood. Certainly what we know is that the number of individuals who can survive on 6 hours of sleep or less and show no impairment in either their brain or their body, rounded to a whole number and expressed as a percent of the population, is 0. So quantity matters, but it turns out that we got it wrong in thinking that was the only thing, because then came quality. So QQRT. Quality is defined in sleep science as 2 things. The first is something that your sleep tracker will measure, which is the continuity of your sleep, meaning do you sleep in 1 or 2 nice long bouts throughout the night? That's good quality of sleep, nice continuous bouts, versus your sort of sleep is very fragmented by all of these awakenings. That's very poor quality of sleep. And the way that you can measure it in your sleep tracker is just by looking at the app, and there'll be something called sleep efficiency. Sleep efficiency is defined as the following. Of the time that you're in bed, what percent of that time is spent asleep? And what we like to see is you north of 85% or above. So this is kind of like the user's guide to sleep trackers. What I want to see is 85% or more. If you're less than that, we need to have a conversation. That's number 1, good quality of sleep. The second, which is what these trackers can't really do, but I can do in the sleep laboratory when you look like a spaghetti monster because I've put electrodes all over your head. I can measure the quality of your big, deep, slow brain waves of deep non-REM sleep. And that is a second measure, the power of those big, slow brain waves. That's a second measure. And quality seems to be as predictive as quantity in making a difference, not just to your all-cause mortality, but quality, even more than quantity, when it comes to mental health has been showing the biggest signal. So again, it's not that quantity doesn't matter. You do have to get sufficient amounts of sleep, but quality as much as quantity should be paid attention to. And I haven't said that enough. Mm-hmm. The next is where we came to in our sort of three things that I was saying. The first is digital detox. Then the next thing I said is regularity. This is somewhere where I've also changed my mind on. I've doubled down on regularity. There was a study that also came out of that same data set that I described. It's called the UK Biobank data. And now they didn't look at 90,000 individuals, but they looked at 60,000 individuals. And they decided that they were going to compare and split them into quartiles. So the most regular to the second most regular to then sort of the third most regular, and then the final quartile was those who were the least regular.
And what does regular mean in this context?
Good question. Highly regular individuals, plus or minus 15 minutes in terms of going to bed and waking up at the same time. In other words, a total wiggle room of 30 minutes.
Oh, okay. So if I'm always going to bed at 9 p.m. and I do that 5 days in a row, I'm regular timing, really.
So it's regularity in terms of when you're going to bed and waking up. So you're right, it's timing in a way. But I'll come on to why there is a separate T for timing in just a second. But regularity here was, okay, plus or minus. So let's say you go to bed at 8:45 p.m. one night, and then 9, and then 9:10 p.m., and then you're back to 8. That's beautiful, tight timing. I like that. Whereas those people who were least regular, they were 90 to 120 minutes disparate. They were going to bed, let's say at 11 one night, then 1 a.m. the next night, then they were going to bed at 10:30 p.m., and then they were going to bed at 12:30. They were all over the map. So what they found was that those people who were most regular versus least regular, so they compared the extremes of these two, those people who were most regular had a 49% relative decrease in all-cause mortality. So they were 49% less likely to prematurely die than those people who were least likely to die. They had a 39% cancer mortality risk reduction. Great. They had a 57% cardiometabolic disease risk reduction. So that was stunning. That regularity was incredibly powerful as a predictive signal of your different forms of mortality. That wasn't the best part of the paper, though. They had also measured quantity as well as regularity in these same individuals. So then they decided to say, well, I'm going to take our measure of quantity and regularity, and we're going to put them both in the same statistical bucket and do a Coke Pepsi challenge to see which one wins out in terms of predicting all-cause mortality. We all bet in the sleep field, or at least I did, it was going to be quantity. I was wrong. Regularity beat out quantity in predicting all-cause mortality, and by quite some margin. Now, that doesn't mean that you can now go away and say, I'm going to start sleeping 4 hours, but incredibly consistent 4 hours. You need both quantity and quality, but goodness, does regularity seem to carry a massive signal. So coming back to those three things, I would say digital detox, just go to bed and wake up at the same time. And the final thing is light. In this modern world, we are a dark, deprived society. We get what I call junk light at night. So you've heard of junk DNA. Well, we get junk light at night. We don't need all of this light, and it fools our brain into thinking it's still daytime outside. So no wonder as a society, we have some struggles with sleep at night. Now, that's due to many reasons: stress, too much caffeine, alcohol, THC. But excessive light is one of the easiest things that you can do. So for the next 7 days, just do me this experiment. If you can, set an alarm 1 hour before your normal bedtime. When that alarm goes off, turn off, and I do this myself, turn off almost all of the lights in your house.
When you say all of the lights, do you mean the little red light on my smoke alarm? Or
No, that's fine. But, so my wife and I, 1 hour before bed, almost all the lights, we've got sort of this little set of this sort of light that goes around the television, the back of the television, so it kind of looks like the television's cool and illuminated. I will set that down to about 5% of brightness, and all of the rest of the lights out. So you can kind of just still see some illumination. So I'm not sort of, looking desperately uncool in front of her when I'm tripping over things because it's complete black, then start cooling the house or the room as best you can to around about 67, 68 degrees Fahrenheit or about 18 degrees Celsius. We can speak about temperature, but just do this experiment for the next 7 days. 1 hour before bed, the alarm goes off. You switch off all of the lights and ask the following question. Do you feel sleepier? Is it soporific? Does it make you feel more sleepy as a result? But don't stop there. What you've gone and done is the first positive experiment, which is you've gone from the no intervention, lights are on, to then the Matt's intervention, which is now the lights are off for 1 hour before bed. Don't just ask, is my sleep better when the lights were out for 1 hour before bed? Once that 7-day period has finished, go back to doing what you were doing before, which is keep all of the lights on and ask yourself, did my sleep get better when I did the intervention? And did my sleep go back to being worse when I stopped? Because I'm trying to teach you bidirectionality in the experiment. Does that make some sense?
Yeah, so you get to basically do an A/B test.
Correct.
Yeah.
You get to see both sides of the equation. And with that, it's more proof positive than just one direction alone, because who knows, it could just be a placebo effect. So regularity, coming back to it, is critical. So we've spoken about QQR, quantity, quality, regularity.
On the regularity point, why? What's going on in our brain that's making it, from a hormonal perspective or other, that's making it important for us to sleep at the same time?
It's a bloody great question. People don't respond to rules. They respond to reasons, not rules. So let me try and explain the reason behind the rule. When it comes to regularity, we have something called a circadian rhythm that we've spoken about. And there's a clock that sits inside of your brain, deep in the middle of the brain. So we have, it just turns out, a brain here. Lovely. Okay, so we've got one of these hemispheres here, and then I'm just going to take out what we call the subcortical sections. So these are the areas that are below the subcortex. So here is the brain. So this is the front of the brain, the back of the brain, top of the brain, and here's the brainstem. And it turns out that right in the middle of the brain, right here, there's an area called the hypothalamus. Now, here, this structure here, this is the thalamus. This is the sensory gate of your brain. So all of your 5 senses, sound, touch, taste, smell, they all flood into this gate called the thalamus. And then the thalamus will decide whether it sends those sensory signals up to your cortex. And when it sends the signals up to your cortex, you start processing them and you become consciously aware of the external world. Now, as we're falling asleep, just as an aside, what's interesting is that this gate, the sensory gate, the thalamus, once we start to fall asleep, the gate will close shut. Now, your eyes are technically still seeing, your ears are still hearing, your tongue is still tasting. But because the gate of the thalamus, the sensory gate, closes shut, those signals that are coming into your brain are no longer sent up to your cortex. So you stop perceiving the outside world, which is just simply a different way of saying you've fallen asleep. Now, the hypothalamus, you've heard of hypo, sort of hypertension or hypothermia. That means lower. So here's the thalamus. This area here is called the hypothalamus. And it's a tiny structure, but within that structure contains a nucleus. And that group of cells, the nucleus, has a fancy term, and it's called the suprachiasmatic nucleus. But the suprachiasmatic nucleus is your master 24-hour clock. Every cell in your body has a clock inside of it. But this is the master clock. It's like Lord of the Rings. There's one ring to rule them all. Mm-hmm. Well, there's one clock to rule them all. And here in the suprachiasmatic nucleus, you get the 24-hour rhythm of being awake and being asleep, being awake and being asleep. How does your brain keep quartz-like precision 24-hour clock time? How does it do that? The way it does that is that it uses signals such as light and dark.
From your eyes.
From your eye. And so when light comes through the retina, it tells the hypothalamus it's daytime, and therefore you should be awake. And its rhythm starts its awesome sort of upswing. And temperature can do this, and feeding can do this, all sorts of different things. But for the most part, light is the principal governor that essentially acts like electrical, photon fingers, that pops the wristwatch dial out and resets it precisely to 24 hours every single day. Because if you're left in the dark with no signals of light, your clock isn't precise. It drifts to about 24 hours and 15 minutes. So you start going forward a little bit every single day if you go into a cave, and people have done this experiment. The thing that keeps it precise is light. So you need light to keep a beautiful 24-hour rhythm. One of those things that's under the control of your 24-hour rhythm is your sleep-wake cycle.
What if I'm doing exercise?
Exercise is a wonderful entrainer of your circadian rhythm as long as you're doing it at the right time. So if you're starting to exercise at 3 or 4 in the morning, that's not good because that's an activity signal that's going to confuse the brain into thinking it's the active period, which is normally, because we're a diurnal species, the day. And it's the same thing coming back to my point of regularity, using light as the best way to help with that regularity, because light, if it's artificial at night, fools your brain into thinking that it's daytime still outside.
I mean, is there any such thing as non-artificial light? I mean, I guess with the sun, but I mean, is there a type of light that I could use at night, like candles or something? Or
yes, below 30 lux
right.
is not going to necessarily do you a disservice, probably below 50 lux. Now, lux, L-U-X, is just a measure of light intensity. And you can download on the App Store a free lux meter. And if you're an idiot nerd like me, you're going all over the house at night and you're sort of putting it in different locations. You're seeing, God, are there any kind of white spots here where, the lux is too high? But you need to drop that lux. By the way, it's a great way if people want to say, look, my REM sleep is deficient. How can I get more REM sleep? There was a great study where they did something similar to what I'm telling you now. 90 minutes before bed, they turned down the lights to below 30 lux and they pulled out all of the blue light. And just that trick of dropping the lights down 90 minutes before bed, below 30 lux, making it warm yellow light, increased their REM sleep by 18%.
Wow.
It's a huge margin. So no need for pharmacology. But to your question, why is regularity important? Well, I told you that light is one of the signals that can create regularity. It turns out that your behavior is another thing that will tell your brain. So meaning when you go to bed and wake up at the same time, it acts like an anchor. It anchors your circadian rhythm. And it tells you, almost like a scene in a movie, this scene is now complete, a new scene starts. This scene is complete, a new scene starts. So every time that you're going to bed at the same time and waking up at the same time, you are feeding the suprachiasmatic nucleus, the master 24-hour clock in your brain. You're feeding it signals of regularity. And when it feeds on signals of regularity, it improves the quantity and the quality of your sleep. Your circadian rhythm likes consistency. It likes regular signals. When you feed it signals of light, of activity, of waking up, going to bed, you improve the quantity and the quality of your sleep. That's the reason behind the underlying rule.
So having a TV in your bedroom is a terrible idea then, because if, on that behavioral point, if I'm getting in bed, but then I'm staying up for 3 hours watching Netflix, my brain is going to be quite confused about like the behavioral pattern of what I'm doing in my life. It's not going to associate the bed with sleep. It's going to associate the bed with movies.
That's one of the problems that we call, it's called conditioned arousal, which sounds a lot more salacious than it actually is. It's a term that we use in sleep medicine, which may explain insomnia. So with insomnia, let's say that the first time you go to this thing called a dentist and you get in the chair and it's kind of cool, you're reclined back and, you think this is fine. But then after about 14 or 15 visits, when you get into that chair, you are no longer looking forward to getting into that chair, are you? Why? Because you've learned the association that being in that chair typically leads to a bad outcome. Now, the same thing is true with the bed. If you start associating the bed with anything other than sleep, and we give you a pass in terms of sex, but sleep and sex, anything other than that, you start to learn that this thing called my bed is this place where I'm awake, where I work, where I eat, where we have conversations, where I watch television. And so, if I were to, and again, I'm stealing Michael Grender's point, but if I were to say to you, bed, sleep, bed, sleep, bed, sleep, bed, sleep, bed,
sleep.
Okay, if I were to say bed, scroll, bed, eat, bed, work, bed, sleep, bed, TV, bed, you've confused,
Yeah.
Because there's no predictive signal. You've never bound an association. Now, the way this works to your disadvantage in insomnia is the following. The insomnia event that begins the insomnia is typically not the thing that maintains the insomnia. So let's say that I experienced a really difficult bereavement, and that triggered a form of insomnia where I couldn't sleep because of the bereavement. Gradually, the bereavement is not the thing that's going to maintain my insomnia. It's because every time I have been going to bed over the past month, I have not been sleeping. I've been wide awake in my bed. So now, because your brain is such an incredibly associative device, it learns the association that my bed is the place where I'm always awake. And what do we then do? We need to break that association in insomnia. So what we do is we say the 20-minute rule. If you've been in bed for about 20 minutes and it's just not happening for you, don't worry. Don't listen to idiots like me that doom and gloom and disease and sickness. And one bad night is not going to be a problem. It's just not. So just say, look, tonight is not my night. I am not, however, going to lie in bed awake, because very quickly my brain starts to learn the association that my bed is the place where I'm wide awake. And you need to break that association. So go to a different room in dim light, just read a book, listen to a podcast, whatever it is. And the rule of thumb is the following: only return to bed when you are sleepy. And so there's no time limit. And that way you gradually relearn the association that my bed is the place where I always get consistent sleep, because otherwise it's the dentist's chair. You walk into your bedroom and you look at your bed and it's your nemesis. And you convinced yourself, even before you get into bed, I'm not going to sleep, because that's the place where I always don't sleep. And by the way, if you suffer from the 3 a.m. awakenings, my first question is, how do you know it's 3 a.m.? And that's your first problem. Looking at the clock does two things. It makes you more anxious.
Yeah.
And second, because your brain is such an incredibly associative device, you start to then decide that 3 a.m. is the time when I need to wake up. If you keep looking at the clock, you keep reinforcing that it's 3 or 4. And sleep at 3 o'clock in the morning is like trying to remember someone's name. The harder you try, the further you push sleep away. Sleep is something that happens to you. It's not something that you make happen. And so at that moment, the best advice, if you don't want to get out of bed, is do any one of the following. Meditation. Just do a guided meditation. You can download apps. Next, if that's not your thing, that's okay. Do box breathing. You can sort of inhale for 5, hold for 6, exhale for 7. There's all sorts of different numbers, but you can do breathing exercises. The third, if you don't like that, is a body scan. So close your eyes, start at the top of your head. Feel as, do I have tension in my forehead? Do I need to relax it? What about my neck? Do I need to move through your body and gradually go down? How are my shoulder blades feeling? I just relax down into the bed and gradually down into the chest, move through and just relax. If none of those things feel fun, the next thing you can do is take yourself on a mental walk. There's a great study from my university, the University of Berkeley, California. And we didn't do the study. Alison Harvey did it. By the way, counting sheep, bad idea. Makes your sleep worse, it turns out. Why is that? Because, well, with every kind of little bleating cotton wool ball with a strange look on its face that leaps over the fence that you're counting, you're reinforcing every minute of sleep that you're not getting, and it seems to make matters worse. But what she found was that there's an alternative. If you think about a walk that you know in great vivid detail. So for me, it's going to be walking the dog. So I go over to the shelf, I open the door. Is it the red lead or I'm going to go with the blue lead today. So I clip the dog in with my right hand. I open the door with my left hand. I take a left down the stairs. I look. It's that level of, I want you 4K detail in terms of granularity. And what's common about every method I've just described, meditation, box breathing, sort of body scan, going on a mental walk, all of these things have in common that you get your mind off itself.
In that particular example where she asks you to vividly think about a journey that you know, what did she find in the study?
What she found is that increases the speed with which you fall back asleep significantly. Because, as I said, it's so, her work to me demonstrated that it is so like that name, because the moment I stop trying to remember someone's name, what happens?
You remember it. Yeah.
I remember it. And so when you do these types of exercises where you're getting the mind off itself, the next thing that you typically remember is your alarm clock going off in the morning.
Is this why people listen to very vivid sleep stories and why I listen to serial killer documentaries?
Serial killer documentaries.
True crime documentaries, I should say. That's a bit more nice to palate.
I don't know of them. My suspicion is that they may be doing your deep sleep a disservice.
Stick up for me in the comments, guys. If you listen to true crime to fall asleep, please write it below in the comment section.
If you find it subjectively wonderfully pacifying and calming, and there is not death, maiming, blood, and limbs being distributed at high velocity all over the scene, I would say it's great. But if it looks like a Quentin Tarantino movie or sounds like one, maybe harm and foul rather than no harm,
like
no
just
foul.
in my ears.
But yes, so, we forget that, to the best of my knowledge, the meditation company called Calm, now I have no affiliation with them, they were doing somewhat well. But what they realized is that they wanted people to sort of meditate in the morning. And when they looked at their usage statistics, people were meditating in the morning. But then there was a huge swath of usage right before bed. People were self-medicating their state of insomnia. And then, through a stroke of genius, they realized when we were young, we used to love falling asleep to our parents, reading us a story. Why is that any different when we become adults? So they created sleep stories. And they went from struggling as a company, I think, to becoming the first, or one of the first billion-dollar valuation health companies out there. They became a unicorn. And now they've got, people like, Matthew McConaughey, they've got Harry Styles, and then occasionally they've got an unfortunate British sleep scientist with a bad voice. But you can listen to these sleep stories and they are wonderfully soporific. Why? Because they get your mind off itself.
We talked earlier on about melatonin, and that there are other supplements which people talk a lot about. One of the ones that's become really popular is magnesium. I've heard ashwagandha, and I've heard magnesium a lot.
Yeah.
Is there any efficacy to these? Are these useful?
The first thing I would say is that if you're suffering from sleep problems and you're looking to supplements, you're stepping over dollars to pick up pennies.
Okay.
What you need to do is think about the fundamentals: regularity, watch your caffeine intake, make sure you're not drinking too much alcohol, get regular, dim down half of the lights, digital detox. Any one of those, but especially all of them combined, are going to get you log orders of better sleep than reaching for the latest supplement bottle of whatever it is. The second thing to say is think about it from a logical standpoint. If there were really some supplement that promises to be the Shangri-La of all resplendent sleep at night, the drug companies would have been all over it decades ago. To put it in context, it took George Lucas, I think, about 30 years to amass something like $4 billion in revenue from the Star Wars franchise. It took Ambien 22 months. That's how big a business sleep pharma is.
Ambien's what's a sleep pill? Ambien
is a sleep pill. Magnesium, if you dig into it, and I did a deep dive about 3 years ago, because I kept hearing it too, this magnesium. The first thing to note is that most forms of magnesium oxide or magnesium citrate, most of these forms of magnesium don't cross the blood-brain barrier. And sleep is produced by your brain. So how can something that doesn't get into your brain affect a brain process number one? There is one form of magnesium that seems to have some evidence in favor of it. It's called magnesium L-threonate. But if you look at the literature, where did this story come from? It turns out that about 30 years ago, they started looking at people who had disrupted sleep, and they would assess their blood work. And what they found is that some of those people were magnesium deficient. And when they supplemented them with magnesium and they became magnesium normative, their sleep got better. But that's very different than saying, look, you and I, we're currently magnesium normative, and then dosing myself with high volumes of magnesium. Am I imagining that that's going to make my sleep better? The analogy would be, let's say I develop this incredible new oxygen saturation machine. And you say to me, well, but Matt, my blood oxygen saturation right now, looking at my device, tells me it's 98.6%. It doesn't matter how fancy or good my machine is. I'm not going to get you past 100%. You're already at ceiling level. And that's the problem with magnesium supplementation. If you're magnesium normative, all you're doing is creating probably expensive urine at that moment in time. Now, there may be an indirect benefit of magnesium in that it does seem to relax muscles. And when the body is in a state of relaxation, it sends a signal of relaxation back up a branch of nerves called the vagus nerve that goes up to the brain and signals to your brain, you're starting to relax down and you get this state of quiescence. And that's very helpful for sleep. So magnesium may still have an indirect benefit on sleep through its relaxation kind of policy that it instantiates in the body. But overall, magnesium is not really moving the needle if you look at the studies. Ashwagandha is different. Ashwagandha and another compound called phosphatidylserine. Phosphatidylserine and ashwagandha, both of these supplements seem to help do one of two things. They either ratchet down the fight or flight branch of your nervous system, and they can also reduce the amount of cortisol that the body is releasing. That's important because I see a lot of people coming to the sleep center where I'm at, and they have what I call the tired but wired phenomenon, where they come to me and they say, I am so tired. I am so tired, but I'm just so wired emotionally and from a nervous perspective that I can't fall asleep. And let's say that you've done, an onstage event, and it's incredible. You've got that onstage buzz. You come off stage at 11 p.m. and normally you'd be fast asleep, but you are so wired, it doesn't matter. You are tired as can be, but you're so wired you can't fall asleep. That's the fight or flight branch being switched on, and you just can't fall asleep. You need to push it back off. Phosphatidylserine and ashwagandha will both push you back over into the more quiescent, what we call parasympathetic nervous system branch. That's good. However, they also will reduce cortisol, and cortisol is a wake-promoting hormone. Cortisol is fine. It gets a bad rap. You need to have your cortisol start to spike a few hours before bed, and it helps with the waking up process. It's wonderful. Every day we have a cortisol spike that starts happening before we wake up. It's one of the things that helps us wake up, and then it builds us to this beautiful crescendo mid-morning where you should be awake and not needing caffeine.
And it drops before bed.
And then it starts to peak in the sort of middle, early afternoon, and in fact usually peaks at the late morning hours, I should say. And then it will start its awesome sort of downswing. And what you see is that right before you go to bed, cortisol should hit its lowest point, what we call its nadir, its lowest trough. Mm-hmm. What's interesting, by the way, just as an aside, is that insomnia we can classify usually as at least one of two different types. There's actually multiple, but let's just say there are, of those multiple, there are two types. One is called sleep onset insomnia. I can't fall asleep. The other is sleep maintenance insomnia. I can't stay asleep. When they've looked at people's cortisol on a 30-minute by 30-minute basis on the 24-hour clock face, we go through just what we described. Just before we wake up, we get this rise in cortisol. It peaks late morning, and then it drops down. And right before bed, our cortisol is almost at its lowest point. With insomnia patients, they show exactly the same thing. A beautiful rise in the late morning hours. It starts to come down, but then you see two anomalies. Right before bed, it goes back up. And then in the middle of the night, even when it's starting to rise, it will have this abnormal spike right in the middle of the night too. And what we believe is that that may in part explain sleep onset insomnia. Cortisol should be coming down and it should stay low right before we go to bed, but then it jumps back up in insomnia patients. I can't fall asleep. And then it continues to stay low throughout the first half of the night, but then it also spikes in insomnia patients. I can't stay asleep.
What you just listened to was a most replayed moment from a previous episode. If you want to listen to that full episode, I've linked it down below. Check the description. Thank you.